Hello everyone. Today let's solve the problem number 17. Let a combination of a phone number. Right. So what the question states here, we are given a string digits, right? So you can clearly see here we are given a string digits, right? So that is from characters in 2 to 9. That is from characters in 2 to 9 within the strings. So this consists of the characters in 2 to 9, 2 3 4 5 6 7 8 9, right? So we have to return all the letter strings that is formed by the telephone keypad mapping for those digits. Simple. So we can return in any order. If digits is empty, then we have to return empty array, right? So constraints they have given here, this one, digits dot length of the digits less than or equal to greater than 0, greater than or equal to 0, and it has to be less than or equal to 4, right? So length of the digits I'm speaking of, it has to be greater than less greater than or equal to 0 or less than and less than or equal to 4. Sorry man, this is fine. Now our digits we have been given 2 3 here. See, we have to return AD, AE, AF, BD, BE, BF, CD, CE, CF. Basically, what we need to do, we have to return all the strings that is formed by the telephone keypad mapping for those digits, right? If digits is empty, then we have to return empty array. That's what they have given here, right? So see here, AD, this one combination of 2 3, AD, AEAF, BD, BE, BF, CD, CE, CF. So this one A, B, C. So this is fine. Now we are done with the question part. So they have given us wonderful examples just for the sake of understanding, right? So let's discuss the approach followed by the complexities, and then let's write the code. First, let's discuss the approach as usual, right? So just give me a second. So this is fine. Let's consider the same first example, man. Right? So just give me a second. 1 second. So yeah, here we have 23, right? So this is fine. So first what we will do, we have 2 3 within the string. So first we will map each digit to its letters. Means 2, in the diagram if you see, so 2 we have, just give me a second here, let me consider this one. 2 what we have, basically 2 is mapped to the letters that are shown in the diagram, right? So 2 ABC, and 3 we have DEF and so on. 3 we have DEF and so on, right? So this is fine. 2 we have ABC, 3 we have DF and so on. So we have to build the strings position by position using backtracking, right? So for 2 3, first what we'll do, we have this one, these two, as we have only 2 and 3, we have these two things, right? So we will be going with a backtracking. Again I'm telling, we will be going with a backtrack approach, right? So just remember this one, we'll be making use of backtrack approach, right? So just keep this in mind, right? So 2 3, when I say 2 3, first what we'll do, we'll pick A from 2. So this one we will pick A from 2, and then we will combine with each letter of DF. First we will consider A from 2, then we will consider this one, then we will combine with each of DF. First this will be AD, and second will be AE, and the third one will be AF, right? So this one we got. So the same thing we will repeat for B and C, right? So same, first we considered AB, now we will be considering B here. So this becomes BD, as we are backtracking, so BE and BF, right? So this is fine. Now finally we will consider C. We'll do the same thing for C with DF. So this one will be CD, CE and CF, right? So finally what we'll do, we'll stop when the built string length equals length of the digits, right? So then we will be adding this one to the answer, right? Answer variable or the result variable, whatever we consider in the code. So this one will be ADAEAF, BD, BEBF, and CDCECF, right? So the output that we got here is, in the result, it has to be ADAEAF, BDBEBF, CDCECF, right? So this is what they have given in the output as well. So let me delete this one, ADAEAF, BDBEBF, CDCE, and CF, right? So whatever the this one output that we got, So basically the output that we got is equivalent to the output that they have mentioned in the example one, for the example one, right? So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach part, let's discuss the complexities quickly, right? So now what will be the time complexity based on the approach that we discussed earlier? So the time complexity would be big O of 3 to the power of n into n, right? So this is fine. Big O of 3 to the power of n into n to big O of 4 to the power of n into n. Big O of 4 to the power of n into n. Let me write instead of dot. I can write into right here. This is fine. Because this here each digit spawns 3 to 4 choices, right? So building strings of length n. So overall time complexity would be big of 3 to the power of n into n to big of 4 to the power of n into n. So what would be the this one space complexity? So space complexity would be big of n. This is for the recursion depth as well as big O of output. So we can just consider here big O of output, big O of n plus big O of output in the sense to store the answers, right? So we have to store the answer somewhere, result variable or the output variable, right? So this big O of n, this is for the recursion depth. As we will be going with the backtracking basically uses recursion itself. So recursion depth can go up to big O of n, we know this, and big O of output is nothing but we have to store the answers somewhere, right? Result AD, AE, AF, BD, BF, we got that one, right? CD, CE, CF. We have to store that one somewhere in the result variable. So this is nothing but the big of output that I have mentioned in the form of output basically here. So output would be I mean the space complexity would be big of n plus big of output. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 3 to the power of n into n to big of 4 to the power of n into n, and the space complexity would be big of n plus big of output respectively, right? So we are done with the complexities part. As we are completely familiar with the output and this one, what do we call, sorry, not output, approach and the complexities, we are good to write the code. Let's start writing the code. First line here, so we need the result list. That's what we discussed recently, right? So let me go with the list here. So this one, this is of the type string. It consists of the type string, so I'll just go with the string. So result, I'll just give r, man. I don't even want to write res here or answer. I'll just go with r. So this one will be new array list. We are considering array list. This is just the syntax part. This is fine. Now we need the length of the input as well. So I'll just go with n here. So this one will be d dot length. So this is Java, right? So this is fine. Now if it is empty input, right? So we have to return r here, right? So output has to be empty as well. So this one, if empty input, then output has to be empty or empty array. So this one will be if n equals 0, we just have to return r. This is fine. Now let's do one thing. Let's this one map the digit to letters, right? So as we had discussed in the approach, so this one will be string m equals new string. This is fine. So within the string, let's map. Let's start from empty string. Again, empty. This is fine. So this one will be ABC, and this one will be for 3. They have given DEF, right? So this one has to be DEF. For the 4, we have GHI. So we can see here, right? Left side. So let me scroll this one. Yeah, GHI. So this one 5, we have JKL. For the 6, we have this one MNO. For the 7, we have PQRS, right? So for the 8, we have TUV, right? So finally for the 9, we have WXYZ, right? So this is fine. Uh, we are done. We are done with this part. Yeah, I so yep, we are done with this part. So next what we need to do, let's go with the current path first. So this will be, I'll just go with P, which is of the type character. So this one will be new char. let me pass the, and we are just going with the current path here, right? So now we have to go with the backtracking, means we have to start the backtracking from the zero, right? So then we have to return all the combinations. These things we have to do. For to perform backtracking, what we need to do, we have to perform I'll be making use of the helper method backtrack, right? So let's write the backtrack function first, or the helper method first, and then let's make use of it within the main function, main method, or the function here, this one, letter combination, right? So let's do that. First let's write the helper method backtrack. I'll just go with private void backtrack is nothing but bt. So this one will be string d int I. I'll just go with the parameter p as well, nothing but the path, current path. So this one we need the result as well. I'll just go with a list of string result variable with this parameter also we need. Finally I'll just go with the m. So this one will be string m. So this is fine. So now within the helper method backtrack, bt I have considered. Bt is nothing but the backtrack. So if path filled, right? So if path filled, then let's convert the character to string, right? I can just write in this way: if I equals length of the d, then what we need to do, we have to convert the character to string, means we have to add that one to the result. So this one will be new string of p. This is fine. Now what we need to do, we don't have to return anything yet. So this is pure backtracking, man, right? So we know this one, right? So let's do one thing. Let's consider the letters for current digits, right? So I'll just go with, just 1 second here. uh, so this is for this one, line number 16. This is for if path is filled for all the positions. We know this one, right? Then we have to convert the characters to string, and then add this one to the result variable, nothing but r we have considered. See here somewhere parameter, yeah, list of string, this one r. This is fine. Now we just have to backtrack here. So this is fine. I can just write it on this way, I guess. I think this works, man. Let's see. So this one will be string s equals, so m of this one will be d dot, let me make use of the caret here. This one I, uh, this one will be hyphen 0, right? So this is also fine. So let me do one thing. uh, we are making use of the letters for current digit, right? So we are going with the letters for current digit. This is fine. Let's try each candidate letter. So let me go with for loop here. Simple. So this one will be int k equals 0, k less than length of the s. So this one will be k plus plus, right? So this is fine. So length, let me give parenthesis here. Hmm, yeah, this is for loop, right? Sorry. Within the for loop, we have to place the letter at position I accordingly with the this one backtrack method, basically. So this one will be p of I equals s dot char at. So we are just placing the letter at position I, right? So finally, we have to recurse to fill the next position, nothing but I'll just go with the backtrack bt we have considered, right? Method name or the function name. So this will be d I plus 1 p r comma m, right? So we are done with the this one, what do we call, we are done with the backtrack helper method, right? So just give me a second here, 1 second. This is fine. Now let's do one thing. We have to make use of the this one backtracking helper method within the, what do we call, main function letter combinations, right? So let's see the same here. So I'll just come here. So let me give here backtrack of uh, d. We have to start the backtracking from 0, right? So I'll just go with 0 index. Uh, so basically, I'll just give here d 0. We have to start from the index 0. This is fine. So this will be p r and m. This is fine. Finally, we have to return the result that is stored in the result variable r, right? So this is fine. Now we are done with the coding part. So let me format the code once and let me hit the run button. I hope this works for the all the test cases. We have the compiler, sorry, compiler. I have missed the semicolon here. Line number 25. I have given the semicolon, right? Error. Oh, for this one. Okay. 25. So let me run this one again. So we have some errors, man, here. Int n equals d of length. Cannot find symbol. Line number 4. So I have considered digits, right? So let me consider d here instead. So I forgot to this one mention d. I didn't wanted to type today actually so much. So this is fine. Error cannot find I equals d dot length. Length we have to give parenthesis. Line number 18, right? So I'll just give here parenthesis. Now this has to work. Let's see. Let me hit the run button here. So see here, the sample test cases are getting passed. Means the code works absolutely correct, right? So let me hit the submit button. Let's see whether this works for all the test cases or not. I hope this works. Let's see. So I can clearly see here, all the test cases are getting passed, right? So whatever the code that we have written works absolutely correct for all the test cases. So I hope the solution part is completely clear, man, for this one. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.